Okay, so we have, up to this point, been talking just about absolute value, solving absolute value. The other part of this then is we're going to look at using absolute deviation. So we've talked a little bit about absolute deviation, but we haven't really talked fully about how we use it, why we use it, and so we've got a couple examples of why or how we would use this practically. So you're buying a new truck. Table shows the value of the different cars at different dealerships. You are willing to pay the mean or the average price with an absolute deviation of at most $2,500. So we're going to look at which vehicles, which of these 5 trucks meet my condition. So the first thing that I need to do then is I need to find the average price of each of these. So I'm going to start with, I'm going to have 38,478 plus 41,987 plus 46,135 plus 44,166 plus 48,234. So when I find average, I add them all up and divide by how many there are. So I'm going to take this divided by 5 because I know that there's 5 different vehicles. So let's pull up this calculator here and figure it out. So I've got 38,487 plus 41,987 plus 46,135 plus 44,166 plus 48,234. Okay, so that should give me, oh, I messed up somewhere. Which one did I? Oh, I messed up the first one. Okay, so this is what you should have gotten, is 219,000. So I'm going to divide by how many there are. Gave me a total of 43,800. So my average for all of these is 43,800. So I have this equation down here. The absolute value of x minus my average equals my deviation. My equation is going to look a little bit differently because we're dealing with inequalities. So I'll have the absolute value of x minus my average, which is 43,800. It's going to be less than or equal to my absolute deviation, which is 2,500. So at this point, we know how to solve these, right? I'm going to break this into 2 equations. I'm going to have x minus 43,800 is less than or equal to 2,500. So it's going to be an and statement or an or statement. Is what we're going to think about next. This is going to be an and statement. Just tell you right away. And x minus 43,800 is greater than or equal to negative 2,500. Okay, so now I just solve. The opposite of subtraction is addition, so I'm going to add 43,800 to both sides. I get x is less than or equal to, let's see, 43,800 plus 2,000, 45,800 plus another 500, 46,300. I'll do the same thing over here, add 43,800. Okay, and then I'm left with x is greater than or equal to 41,300. So I could write this as one long inequality, right? This is an and statement, which means that I can write one long inequality. So if I were to do that, my minimum is 41,300 is less than or equal to x is less than or equal to, my maximum is 46,300. So the truck that I'm going to buy needs to be in between $41,300 and $46,300. And this is super practical, right? So like one day you will probably buy a car at some point in your lifetime, and you need to go on a budget, right? You need to think about, well, especially in new cars, you're going to look at like, what's the average? What does it sell for on average? And then you're going to base what you will pay off of it based off of the average of what other people paid for it. So this is super practical. So now I need to look through and see, well, which ones fall in this range. My Toyota Tundra does not. The Nissan does. The Nissan does. The Dodge does. The Ford does. Whoops. The Chevy does not. So it looks like I could buy the Ford, Dodge, or the Nissan. And that would fall in my range. Another thing that we'll use absolute deviation for is to kind of figure out if our average, if the mean of the set of data that we're working with is actually a reliable way to analyze my data. So we'll show you what I mean. I keep calling these class A and class B, so I'm going to change this to A and B as I'm talking about this. A, B. So Mrs. Olson wanted to evaluate how her students did on their test by averaging their test scores. So we're going to find the mean absolute deviation for each class to support our answers to the questions below. So is the average test score a reliable way to compare the grades in these two classes? Is it more fair for one class over another? Why or why not? So my first step then is just going to be to find the average. So I need to find the average here, and I need to find the average here. So I'm going to pull out my calculator again. Oops. Move it over here. Okay. So I've got 88 plus 94 plus 91 plus 85 plus 90 divided by 5. Okay, my average over here is 89.6. And I'm going to do the same thing for the other guy. So I'll have, oops, clear, 94, 86, 88 plus 91 divided by 5. Okay, my average here is 72.8. Okay, so I have my averages. Now I need to figure out what is my mean absolute deviation of the data to my averages. So let's look at, here's class A. My first value for class A is 88. So this is what this is going to look like. I'll have the absolute value of 88 minus my average, 89.6, plus the absolute value of my next one, 94. So on and so forth. 91 minus 89.6 plus absolute value of 85 minus 89.6 plus the absolute value of 90. Okay. And then I'm still going to divide all of this by how many I have, which is 5. So what I'm doing here is I'm finding the absolute deviation. I'm figuring out how far away is each value from my average. And then I'm going to divide that by 5. That's going to tell me on average how far away each of my values is from my mean. So what I like to do in this case is I like to go through and write down what each of these distances is, and then that makes it a little bit easier for me to solve. So I've already written these down, so I'm just going to go through them. So this is going to be 1.6. Over here I've got 4.4, 1.4, 4.6, and 0.4. So then when I go through and add these up. Hit clear, got 1.6, oh, I gotta move over here, plus 4.4 plus 1.4 plus 4.6 plus 0.4, and divide that by 5, gives me an absolute deviation of 2.48. So I'm going to write that up here. 2.48. Okay, now I'm going to do the same thing for class B. I'm going to have the absolute value of 94 minus 72.8 plus the absolute value of 86 plus 88 minus 72.8 plus the absolute value of 91 minus 72.8. All of that divided by 5. Whew, that's a lot of work. Okay. So I'm going to do the same thing. We'll go through. This should be 21.2, 13.2, 67.8. Oh, I just did 68.8, 67.8, 15.2, and 18.2. This one's a little longer, so I just went ahead and did this one. Also, so when I add all these up and divide by 5, I should get 27.12. Okay, so now I have all the information that I need to evaluate where I'm at with this. So Class A, or Class 1, has a mean absolute deviation of 2.48, so essentially 2.5. That tells me that every test score that I have in my list is on average 2.5 points away from the average, which means that those are pretty close together, right? So that tells me, yeah, the average is a pretty good indicator of how the class as a whole did. For Class B, my mean absolute deviation was over 27 points away. So that tells me that on average, every test score is 27 points away from my average. Well, if I look at what my test scores are compared to my average, most of them, well, all of them except for one, is over 80, right? So are any of them even close to 72.8? They're not, right? Would it be fair for me to look at that list of test scores based on the average and decide that the class as a whole didn't understand the concept that I was teaching? No, that doesn't make sense, right? Because most people on that list, 4 out of those 5 people, did completely fine on the test, right? They had no problems whatsoever. There's just this one person right here, not the 88. Ugh. There's just one person on this list that didn't do so hot, and it's this guy, right? The 5. The 5 completely throws off our data. So the average in this case is not a very good indicator of how well they did on their tests, right? Because a majority of them did way better than 73%. And so that's kind of what we're looking at here, right? Is in the first case, the average was a pretty decent representation of the data that I have. In Class B, it's not at all. And so that's one of the ways that we use absolute deviation. Okay, we got a couple practice problems here. I think I'm just going to have you do those on your own. And then there will also be an assignment and big ideas over this as well. So this is the end of 2.6.